Yeah, hi everyone. I'm Vijay. I'm from Marvell, and I have originally joined OPI meetings at the very beginning, so I recognize some of the names here. But later, I was like not participating much. So today, me and Paul are going to talk about how we move forward from what Balas has presented. So in fact, we are working together, Red Hat team, Marvell team, and F5. We sync weekly on this. So it's the same talk actually. We don't want a very big talk to and bore you guys. So we have broken it. So it's like a continuation of his talk. We will go little south from what he has presented, and then we will talk about two NFs which we have packed, which are like deployed with OPI compliance and also configurable also with OPI APIs. That's the talk, and I'm gonna cover the initial slides, and I'll ask Paul to join then for the Nginx part, right? Okay.
Sure.
You want to say something?
No, I'm good.
Okay.
So
Okay, let me start.
I'll introduce myself.
Yeah, okay. Yeah, so basically this is like continuing of what we are doing. What Balas has explained is like how we are deploying the OPI compliant functionality on the DPUs. And I want to start from where we have started and how we collaborated and why we collaborated with Red Hat, and for what aspects we have looked at OPI and how we are leveraging OPI to actually make a really production grade usable solution. That's where we are right now. I just want to cover the journey, like how we got there. Okay, so this is where we have started. So this is Marvell's IPsec solution. So as you can see on the DPU, our stack is built on VPP. It's open source VPP, and we have a plugin which is part of like VPP. It's a VPP plugin which is also open source. So when you use this plugin with VPP on an Octeon card, it leverages all the hardware functionality there. So this is like you get line rate crypto performance with this solution, and it's already used by the customers. It's already deployed, right? So, but there are like, so even though this is like a performance wise, it's a very good solution when you deploy it as a monolithic application on the DPU. When you want to bring it to cloud native environment, it has like quite a few issues, right? So one is there is no lifecycle management. We cannot uh, launch and recycle the application on the DPU, which is our VPP, in a cloud environment, right? Like it's like done very statically. So we launch the VPP, and that's it. Like it's a one big application which connects to all the ports which are towards the host side, and then you don't know which ports are connected to which apps on the host. So then you have to manually do the mapping and then send the traffic so that it comes to the right ports and do everything manually, basically, right? That's the second pain point, right? The VF mapping is very tough and it's very static. You cannot allocate and recycle resources dynamically. So that's the second problem there. And then we have, so once you do all that, like how Bala showed, like how you launch things, and then you have the other problem, like for any standardized application, how do you configure it? So there should be like a standardized way. So with VPP, if your data plane is VPP or XFRM, you have to log into your DPU and maybe use VPP CLI or use Linux shell to actually configure your security policies. There's no other way, right? So there are some workarounds for that, but it's not really there. So as a first step, we implemented, before even collaborating with Red Hat, we actually simply implemented, to move to Kubernetes environment, we simply implemented a SRIOV CNI for Marvell. So we just get a secondary port, which you can connect to DPU, but the story ends there, right? Like the port is there on the DPU, but then it's like you have to still do the manual plumbing, connect to your data path, and then configure it. All the other problems remain the same, right? So this is the work which we did with Red Hat. So this is the DPU operator. There are like so many components shown here. I think Bala's covered few aspects. So I want to cover some other aspects which he didn't touch on. Maybe he did it in the past sessions, I don't know. So basically, for the problems which I just said, like you launch a VF at the beginning on the user pod, and then that particular VF, you have to send it to that information you have send it to the DPU, right? So that for that we have all these components which actually pick up which port you have connected and send that port information down, and then you add it to your workload, which is your, in this case, IPsec application. I'm taking IPsec as an example, but it equally, all this discussion equally applies to something like Nginx, which we will talk about later, right? And then you have to do the plumbing in the on the DPU, like how you connect that particular port to your, direct the traffic to your NF. So we implemented in a very generic way. So there is a programmable data plane here. It's right now based on OVS. And you can actually link more than one network functions. Let's say you have load balancer and then IPsec. You can actually link both in this scheme. Right now the facility is there. So we worked on this with Red Hat, and we also developed the vendor specific, basically Marvell specific plugin for this. So this is like one step which we did, and then we have this other problem. Like now you have your IPsec loaded. Maybe I should hold my mic closer. But you still have the problem of like, how do you configure your IPsec? So you still have to log into your NF and then configure it. So that's where we turned into OPI. So we leveraged OPI for this third problem. So we use the OPI bridge concept. So I'm assuming most of the people here are familiar with OPI bridges, but I'll just have a brief. So it's not like what it sounds like. It's not really a bridge. It's just a translation layer from your gRPC, a common standard gRPC layer. You implement the southbound of it to, every vendor implements in their own way. So there are like different bridges for different groups of applications. So storage, networking, and security. So we will be talking about storage because I'm demoing all this with IPsec, right? So this is how the XFRM, the strong swan bridge works. So you get a gRPC client, which is like, you can say OPI compliant bridge, OPI compliant entity, which is outside. It's a client here, which is given by, so this is like OPI code we used, but it could be like a security orchestrator using the same APIs to talk with the strong swan bridge. So the strong swan bridge in this case talks with strong swan using wiki message format, which is also pretty standard thing. So then once strong swan gets the OPI message, it actually exchanges the keys with the other end, and then it basically programs your data plane. So that particular programming of the data plane, there are like multiple ways. So OPI recommends that you have a plugin inside your strong swan to actually pick that information and program your data plane, like however you do that. So at Marvell, we have like two ways which we did it. Like we have two solutions. So basically, we created like two network functions for doing that. So if you see the left one for VPP based data plane, we actually snoop the XFRM information using a plugin inside VPP, and then it configures the VPP. So basically, the VPP solution which we talked about earlier can actually leverage this solution from the external configuration till the hardware. So VPP anyway offloads to the hardware, right? Crypto engine. So you get the same line rate with this solution. And the right side one is the other one where we use XFRM offload. So we let the strong swan configure XFRM, and we install the crypto driver on the Octeon, and it actually offloads the crypto part. So the difference is that here it's only doing crypto offload. The left side one is like complete IPsec offload, right? So I'll go over a demo now. So this is the demo setup. So we have just one node. So in the earlier demo which Bala showed, you have like multiple nodes in the cluster. So this is also same cluster. The only difference is like in their cluster, they recently combined the DPUs and host to the single cluster. But in this, it's different. That's the only difference. So the DPU here is running Microshift and the host is in the OpenShift cluster, basically Kubernetes cluster, right? So you have this OPI client at the here, which is external entity, and we'll see how things are launched and how OPI client configures things so that IPsec, the configuration goes through all the way till the hardware, right? So let me. So I have a recorded demo for this. So don't worry about the time. I have actually a small cheat sheet to actually go to the good parts of this. It's a very long demo. The reason we created this is like the intent is to actually add this demo to the OPI demo folder so that it will be easy. So that's why it's very elaborate, explaining every step with some comments and things like that, right? Okay. Right. So here we are launching. So basically, I have like different tabs at the top. Like the DPU operator is the tab which basically you are launching all your pods, like the pod on the host and also the NF on the DPU, right? That's the beauty of this. You launch your actual user pod and also the related workload, and the plumbing automatically happens. So that's the crux of the solution, right? So here we are launching both. So the SFC pod is the one which is the IPsec NF, which uses OPI APIs, and the host pod is the pod which is running on the host, right? So, and then I go to the, just showing that the pods are running, and then, so this is the external test system where we launch a strong swan agent there. That's the guy who talks with the, basically the data plane testing. So that there you have one pod there. So we just want to see that there are no policies, right? It's all empty now, it's blank. And then we go to, so same with the launched IPsec OPI NF. So NF is also empty. So now we have set up things that we have launched a user pod and a offload pod on the DPU and the external entity. So the traffic is going from the external entity via DPU encrypted and out to the outside system, but the configuration is all empty. So now we can use OPI client to actually do all the configuration from outside. So for this all the way I will. So it's actually showing a lot of route setups and things like that just to show how things are working. So I'm skipping all that. So this is the OPI client. So we just run the OPI client from here. It sends the OPI message to your strong swan bridge, which is running on the NF, and it does the configuration. Right. So you don't need to log into any of this. So this can be done by your cluster security orchestrator logic using the same API. Right. And then I skip. Right. So now we are actually seeing that the configuration is done on both the systems. On the NF and also the external test system, both have the configuration created by key exchange. Okay. Yeah, this is on the NF side, right? So now we can do the actual send some packets and do some testing things because things have set up. Okay. Okay. So we're just checking the hardware counters on the DPU before sending packet. Did I pause it? Okay. Then we will set up all the TCP dumps everywhere just to see that, and then all right. Right. So that's the main test, right? So and we can actually see that it's done by DPU hardware, right? Connecting like the total north to the the actual configuration. Okay. Right. So let me go back. Right. So that's the main goal actually, like leverage OPI to actually convert our existing production grade solution, which is like OPI compliant, so that the users can easily replace that with the other one. You have the launch, plumbing capability, and configuration capability all with that. So we have two NFs like that, which we did for IPsec. One is the XFR and script offload, and another one is full IPsec offload. And we also have the Nginx one, and we are doing some work on that. And Paul will talk about that part.
Sure. I'm Paul Pindell. I'm a principal architect at F5, and I've been part of this group, OPI, since the beginning, and done a lot of work here. What's you've seen Nginx Plus running on the DPUs and IPUs. So Balazs showed that. What is that doing? It's acting as a proxy on there, and it's proxying traffic and securing traffic as it comes into the host, and we're offloading those infrastructure functions to the DPU, and then only allowing traffic that the Nginx allows through actually to get to the host where the workloads are running. That's essentially what it's doing. We showed that. I showed that at a conference at OCP, I think 2 years ago. And we did that on the Marvell card, on the CN106. We did that on the Intel IPU, the E2100, and on the Bluefield 3. I don't wish anybody to have to do what I had to do to make that work 2 years ago. The interesting thing here is that we've got the DPU operator and a OPI compliant set of APIs to abstract some of that difficulty and make it easier for everybody to use. So yeah, Nginx, yes, we sell Nginx, go buy Nginx. I love that, that's great. But that's not the interesting part here for OPI. What's interesting for your OPI is that we made it easier for customers to run the workload of their choice on the cores on these DPUs and IPUs in a standard, easy to use fashion. And so Red Hat had a very big hand in that, coming up with the DPU operator and making it such that you've got a pod running on the host and a pod running on the DPU or IPU itself. They communicate, and then thanks to the vendors like Marvell and Intel, they've created and done the hard work of creating these vendor-specific plugins, and those are where some of the magic lies. So that's where configuring the P4 rules, using the Marvell SDK, using Doka, those sorts of things you don't have to do anymore to wire up the network paths that you need to make these solutions work. That's all taken care of by, we've abstracted through the DPU operator some of those functions that you want to have happen in the way that you want these cards to be wired up to the host. That's been abstracted through the vendor-specific plugins. So no longer do you have to learn P4 and Toka and the Marvell SDK to make this work on all three cards. You just need to learn the one OPI API standard that is used through the DPU operator. That's the real value add for these demos that you've seen. And the same thing applies to the IPsec portion. There are, we didn't call them vendor-specific plugins. We called them bridges for the IPsec. But each vendor created those bridges for their card so that we could show how to get that very same strong swan functionality running on all of the various DPUs. We're going to see in a later session another workload running on a DPU, and it's going to be, we'll talk about that in a later session here. But for this one, the Nginx Plus is, again, sitting there and acting as a proxy and a security barrier between the outside world and the host. So no traffic that isn't allowed through by Nginx ever gets to the host, and thus we're securing the, in this case, we were running an AI workload on the host. It just so happens that it's Intel OpenVINO. That's the inference server that's running there on that host. And we're protecting that model and that inference server from the outside world with Nginx. But again, the real value add here is that OPI APIs that are implemented through both the DPU operator and the vendor-specific plugins make it easier to deploy and makes it easier to, like Bilal showed, move an instance from one DPU to another without having to understand the underlying, how to wire that up for each of those cards and make it function. And any questions on that and what we did there? Not all. Are you supporting PQC as an offload on the CN106?
I'm not sure. I need to check that one.
Okay.
I'll get back to you.
Yeah. Yeah, yeah. Any other questions? And were there any online? Venkat, did you see any come in online? I didn't see anything flash up on the screen, but.
Can you talk about the telemetry support in there for the network function as OPI as any?
Are there any telemetry functions in there?
Yeah.
Not as part of these demos. We have this OTel is supported on as an OPI standard, but I'm not sure that that's been plumbed into and created bridges or VSPs for each of the cards. Balash, do you know if that's been done, any OTel stuff?
So regarding metrics and telemetry, we've done a demo at some point where we created our pod that is doing some kind of measurement and exposing that. Since OTel and all these metrics and Prometheus and whatnot in Grafana, you can use those in a standard Kubernetes environment already, right? And since we're extending Kubernetes to the card, we also extend all those capabilities. So even though we didn't particularly try that, a lot of these things turn out to be pretty easy and turn out to just work because we've integrated into existing environments in a standard way. So the answer is no, we didn't try. However, based on what we know from the past, it might be a very small lift.
That would be my guess. Hello? Yes, that'd be my guess. Any other questions? Or was that it?
In the earlier presentation, like pods were shown, like can they be made as AI agents and they communicate with other pods as AI agents to agents communication using Google's A2A protocol?
Yeah, I
Again,
think,
it's Kubernetes, so I don't see why why you couldn't run those on the card as well. It's just, they're simply pods running. The Nginx is simply a pod running on the DPUs. Yes.
Yeah, so again, it's just pods. And if the card, like from this forum perspective, if the card has, let's say, a chip that can accelerate some of the LLM inference capabilities, and I do believe Marvell's card has that, then that pod can then leverage that hardware. And then, of course, talking A2A is just a part of protocol, right? There's no gating thing happening here. It is open from that perspective, and it's almost orthogonal. So A2A would also be orthogonal, like, yes, of course, but you can also do it on the host. And because the card is just another server in a server, you can do it on the card as well.
yeah, just to add to that, basically we are looking at accelerating MCP on the DPU. So in that case, that kind of pod would be running on the DPU, and your agents or the server side of the agent would be running as a pods on the host. That's a possibility. We are actually looking at using Nginx Plus for that, right?